Now let's walk through a real-world example that shows exactly when GPU acceleration becomes the perfect solution. Imagine you're looking at a 4K image. That's about 8.3 million individual pixels. And your task is simple. Increase the brightness of every one of those pixels by 20%. Let's begin with how a CPU handles this kind of job. A CPU processes pixels one at a time in order. Even though each pixel is processed very quickly, the CPU must visit all 8.3 million of them sequentially, which means the total time adds up fast. Now let's contrast that with how a GPU approaches the exact same task. The GPU divides the entire image into many blocks and assigns each block to a different GPU core. Instead of processing pixels one after another, the GPU handles many blocks and therefore thousands of pixels at the same time. That is, seconds or even minutes on a CPU becomes nearly instantaneous on a modern GPU. So, when should you reach for a GPU instead of a CPU? There are three key criteria. First, the same operation must be applied across all data points. Second, each operation must be fully independent. And third, your dataset must be large, millions of elements, to truly benefit from parallel execution. When all three criteria are met, you have an ideal GPU workload, where parallel processing unlocks exponential performance compared to traditional CPU execution.